In this session, we'll discuss about reactions of fatty acid synthesis. Objective of this session is, at the end of the session, the learner shall be able to describe reactions of fatty acid synthase complex. There are a total number of 7 reactions are there. By the end of the 7 reactions, there is a synthesis of long chain palmitic acid. Okay. The first one is transfer of acetyl coenzyme A to enzyme. Okay. Then let us see. Now let me first draw the enzymes of all the various reactions. Okay. So these are enzymes. So these are enzymes homodimer. Okay. It contains SH group and also it contains SH group. Okay. To this enzyme, so there is a transfer of acetyl group, that is CH3. It is acetyl coenzyme A releasing the coenzyme A. What is that enzyme? Enzyme is acetyl coenzyme A, ACP transacylase. Okay. Then, so how it looks like? Let us see. Here it is SH. Here it is the acetyl group is transferred to the ACP. So that is called acetyl S-ACP. Acetyl S-ACP. So what is the next reaction? Let us see. What is the next reaction? In the next reaction, so what happens? The acetyl group which is present at the ACP is transferred to the cysteine SH. So how it looks like? Let us see. Again here. Okay. Here. Okay. Then this becomes free. So this one is the post reaction. This is also post reaction. This is also post reaction. In this, what happens? Transfer of acetyl coenzyme A, okay, to cysteine SH from the ACP SH. Okay, what we call this one? It is acetyl S enzyme. This is called acetyl S enzyme. Okay. Then what will be the next reaction? In the next reaction, so there is a transfer of malonyl coenzyme A. There is transfer of malonyl coenzyme A. The transfer of malonyl coenzyme A is taking place. Okay. Then, so the malonyl coenzyme A is taking place. Okay. Then, so let us see how it looks like. What is that enzyme? Malonyl. Okay. Coenzyme A, ACP, transacylase. Acylase. Now all the reactions will take place on ACP SH. Okay, let us see how this enzyme complex looks like after this step. Okay, here it is. Acetyl coenzyme A is there as earlier. Then the malonyl coenzyme A is here. Okay, here the coenzyme A is released. What we call it this one? Acyl malonyl enzyme. We call it acyl malonyl enzyme. So what is the next step? The next step is release of carbon dioxide, CO2. release of CO2. Okay, carboxyl group is released. Okay, so what is that enzyme? So beta keto acyl ACP synthase. ACP synthase. In this step, what is happening? In this process, so the acetyl group is transferred here to this ACP, okay, combining malonyl and acetyl group, releasing the carboxyl group. That means the carboxyl group which is incorporated at the time of synthesis of malonyl coenzyme A from the acetyl coenzyme A is removed. Let us see after this reaction how this enzyme looks like after the combination between acetyl group and malonyl group releasing the carboxyl group. Okay, this will be the SH group and here, okay. So it is the joining of acetyl and malonyl group has taken place. So what we call this one? Beta keto acyl ACP. Beta keto acyl ACP. This is the reaction of the fatty acid synthase complex where, okay, the NADPH is required. The NADPH is required. NADPH is required. Let us see here the NADPH is required. NADPH, so plus H plus, then NADP. Okay, NADP reduction is taking place. What is that enzyme? Beta keto acyl ACP reductase. Okay, reductase. Then how this complex looks like? Now let us see. Again it is same here. Okay. So this is, so reduction has taken place here. Reduction has taken place here. So what we call this one? Beta hydroxy acyl ACP. Beta hydroxy acyl ACP. Now the removal of water is taking place. H2O is removed. What is the enzyme? Beta hydroxy acyl ACP dehydratase. Okay, dehydratase. Then, so how this complex looks like? You can see here. Okay, it is same. Okay, then here it is. A double bond is created. So it is called as trans. It is called as trans. Okay, enoyl ACP. Okay. So what is the next step? What is the next step here? See, again, in this reaction, second step, where NADPH is required. Reduction reaction, NADPH plus H plus leads to NADP plus enoyl ACP, okay, reductase. So reductase, enoyl ACP reductase. After this reaction, how this complex looks like? After the reduction reaction, how this complex looks like? Okay, let us see. We get fatty acid with, okay, 2 carbon more. What we call it? Butyryl ACP. Butyryl ACP. 2 carbons are increased. Let us see what is the next step. In the next step, so transfer of carbon from ACP to cysteine is taking place. ACP to cysteine is taking place. Let us see after this one how it looks like. Okay, so here, okay, here it is then again SH group free. Okay, acyl yes enzyme. Okay, then so up to this one cycle of fatty acid synthesis is completed. Let us see what are the various steps. Go back and check it. The first one is transfer of acetyl coenzyme to enzyme. This is what happened. In the next one, transfer of acetyl coenzyme to cysteine SH. In the next step, what happens? It's a transfer of, okay, so this melanyl coenzyme A has taken place, resulting this complex. Then what happens in this one? So there is a combination of acetyl and melanyl group that is taken place. Combination of acetyl and melanyl group has taken place. Now, so there is the reduction. The reduction has taken place. Okay. Then in the next one, so there is a dehydration, leaving behind double bond. Again, the second reduction. Okay. Then finally, there is a formation of butyl ACP. Now again, transfer of butyl group. Butyl group is taken place from ACP to cysteine, ultimately leads to acid S enzyme. So these reactions, they are going to be repeated. There are total 6 more rounds it will take place. So what happens here? Okay, 2 to 6 reactions. Okay, 2 to 6 reactions. So repeated. 2 to 6 reactions repeated. That is how many times? Let us see here. Okay, 1, 2, 3, 4, 5, 6. Okay. Finally, leading to the formation of again SH. Okay. Then yes. Okay. Then here. Okay. Then so like this, we are getting the palmitic acid having how many carbons? 1 to 13. Okay, 15 plus 16. Okay, the palmitic acid synthesis is completed here. Here we call palmitoyl. Okay, ACP. Palmitoyl ACP. Okay, finally what happens? So there is thioesterase. In the presence of thioesterase, what we get is enzyme is released, multi-enzyme complex is released, releasing the palmitate. Okay. Releasing the palmitate. Okay. So we have one more, the carbon. Okay, palmitate. Okay, so these are the various reactions. This is the first. Also, here this is also first. The second one. Okay, then third reaction. Okay, then fourth reaction. Then fifth reaction. Okay, then sixth reaction. Okay, so these are the various reactions which are taking place. As far as the palmitic acid one is concerned. Okay. Summary of palmitate synthesis. Okay, so let us see that 2 carbons from acetyl coenzyme A out of 16. 14 carbons are from melanyl coenzyme A. Of course, melanyl coenzyme A also comes from acetyl coenzyme A. Let us see acetyl coenzyme A and such, and after conversion of acetyl coenzyme A into malonyl coenzyme A, putting these together, see the overall reaction. Okay, 8 acetyl coenzyme A, okay, plus 7 ATP, then 14 NADPH plus 14H plus, okay, leads to palmitate 16 carbon palmitate, okay, plus 7 ADP plus 14 NADP plus, okay, 6H2. So this is the overall summarization of the synthesis of palmitate. In this session, we have discussed about reactions of fatty acid synthase complex. Let us summarize. This is the multi-enzyme complex. So one side it is cysteine SH and another one is ACP. This is the active enzyme. Okay. In the post reaction, transfer of acetyl group is taking place. Acetyl CoA. Okay. In the presence of acetyl CoA, ACP transacylase releasing the coenzyme leading to the formation of acetyl SACP. Okay. In the next reaction, this is also reaction 1 where the transfer of this acetyl group from the ACP to cysteine is taking place, okay, leading to the formation of acetyl S enzyme. In the second reaction, the transfer of malonyl group to ACP is taking place. So by the action of malonyl coenzyme A, ACP transacylase, malonyl coenzyme A is supplied and coenzyme A is released, leading to the formation of acetyl malonyl enzyme. Okay, then in the third reaction, there is a reaction between acetyl and malonyl groups are taking place. Acetyl is shifted to the ACP and attached to the malonyl group by the action of keto-acyl ACP synthase. Okay, leading to the formation of beta-keto-acyl ACP. Then, in the fourth reaction, the first step of reduction is taking place. NADPH is supplied, releasing the NADP by the action of keto-acyl ACP reductase, okay, leading to the formation of beta-hydroxy-acyl ACP. The next reaction, that is the fifth reaction, where water is removed, that is dehydration step, by the action of beta-hydroxy-acyl ACP dehydratase, creating a double bond, leading to the formation of trans-delta-2-enoyl ACP. In the sixth reaction, reduction is taking place. That is the second step of reduction. Okay, NADPH is converted to NADP plus by the action of enoyl ACP reductase, leading to the formation of butyryl ACP. It is containing 4 carbons. Okay, we have started with the 2 carbons. Now it has become doubled. Okay, then, okay, with this we have completed the 6 reactions. Okay, then in the next reaction, transfer of carbon chain from ACP to cysteine is taking place. That means butyryl group is shifted from the ACP to cysteine, leading to the butyryl S enzyme. Okay. The reactions from 2 to 6, they are repeated 6 times, leading to the formation of 16 carbon palmitic acid. With this, the completion of fatty acid synthesis. Okay, once palmitic acid is synthesized, it has to be released from the enzyme by the action of thioesterase. That is what we call thiolytic cleavage. This is the final step leading to the release of palmitate and free enzyme. This enzyme can again synthesize another palmitic acid starting from the acetyl coenzyme A. Okay. Let me give the summary of palmitate synthesis. 2 carbons come from the acetyl coenzyme A, 14 carbons from malonyl coenzyme A. Of course, malonyl coenzyme A is also synthesized from acetyl coenzyme A. Okay, we will see the overall reaction. 8 acetyl coenzyme A, 7 ATP required, 14 NADPH, 14 H plus. Okay, synthesizing palmitate, releasing 7 ADP, 14 NADP and 6 H2O. With this, we have completed the palmitate synthesis through the multi-enzyme complex. Okay, thank you very much.